So in our first video on logarithms, what we're going to be going through is an introduction about what logs are, how they're related to powers, and also how we can write logarithms as single expressions and write them in index notation and vice versa. So a logarithm is just the power that a number needs to be raised to produce a given value. So logarithms is just like another way of us working with powers, as we're more familiar with working with index notation in the past, where you've got a base number and you've got a power. So it's a bit like Pepsi and Cola, PS4 and Xbox. It's just another way of doing something that you're more commonly used to doing. Now, although it's very difficult, you're learning a new skill and learning a new type of way of writing something, but this is how it was done originally. And so it's a case of just going back to the fundamentals of maths and how things were before, let's say, things became a little bit more efficient. So before now, we used index notation to represent powers. And when we say before now, it's a case of what we've done in the past rather than what was set in stone. But sometimes it's easier to work with log notations. So in log notation, when we have 3 to the power of 5, it means 5 lots of 3 are multiplied together. 3 is known as our base number and 5 is our index, which is more and more mathematical word for power. So if we refer to this now, although this may seem a little bit odd, so here our 3 is the base number, and if I get our 5 is what we call the index, in other words the power, and 243 would be our answer. So that's what we're more commonly used to. Now if we then go into discussing more with regards to logs, and if I just move down, so they were more commonly used to using log notation to calculate the base and the index is known. We can use logs to solve equations when the variable is a power. So if you think back into the past, whenever you've gone to solve an equation using algebra, your x has always been the base number. It's never really been the power, and if it has ever been the power, then we probably have to use trial and error to work this out. So the question is what happens if the x is a power rather than a base number? And that's where logs come into play, and this is where logs is really key. So, and this sort of explanation here is one that is really, really important. So if we had a to the power of x, and that obviously gives us an answer of y, then we can write this in log form as log to the base a of y equals x. So how we write this is log to the base a to y equals x. So here, as you can see, in this particular example, so if I get a different colour pen, so here, as you can see, my x is the power, whereas in this particular side, x is my subject. So if x was, let's say, my unknown in a particular question, then I could use this notation of logs to work this out. Now you may have always wondered what your log button on your calculator does, and this is basically where it comes into play. So moving on from that, if we have an example here, so if we had 2 to the power of 5 equals 32, because 5 lots of 2 multiplied together gives us 32, then how I can write this to make 5 the subject is I can say that this is log to the base 2 of 32 equals 5. And again, this is something that I can type into my calculator. Now, it's important that when you're dealing with logs, that on your scientific calculator you may have a button that looks like this, in which if you do have something that looks like this, this is where you could enter it in. So if you were to type in and fill in those numbers of log 2 of 32, press equals, so log 2 of 32 equals, then basically it should give you the answer of 5. And basically what that is saying to you is that 2 to the power of 5 is equal to 32. Now, moving on from that, if we go from here, so The logarithm, or how we abbreviate it, is just calling it log. To the base of a number is the power to which the base must be raised to equal that number. So now, just as there are laws of indices, there are also some comparable laws of logarithms as well, and this is where these come into play. Now, if I just go into more detail about what these are. Now, if you think back to the laws of logs, where one of the main laws was when the bases are the same, that when you are multiplying, we add the powers. Now here, when we are multiplying, we can split. So when we've got log x to the base x, and we've got a product of two numbers, then we can split this up into two separate log calculations, where, although our base number is the same, we can split this AB into two separate terms. And again, I'll go through some examples of what this is. So the key way to remember it is, when do I multiply? What do I do when I'm multiplying powers and the bases are the same? Well, I add them, or here we add, and then we can multiply these values here together. And likewise, when do we divide? So another law of logs is when we are dividing, we take away the powers. So here, when we are dividing, we can write this as two separate logs where we are taking away. Now, the third law is just another way of rewriting something. So if we had something, so if we had 3 log, let's say 2 to the 4, then I can rewrite this as log 2 4 cubed, which would be equal to log 2 of 64. Okay, so it's just another way of writing these things. Now, you may be asking yourself, well, what is the whole point of this? Well, when we look through examples of where we are rewriting logarithms or complicated logarithms as a single logarithm to try and solve equations, that is your end game, is to solve equations, and that's how we can use logarithms. That's the whole point of these using logs, is to solve equations when your x is a power. So if we have a look at some examples using that particular rule, now it's worth mentioning that the rule that we're going to be using and referring to is this one here. So in this particular question, we're asked to write these in single logarithms. So what we're going to do is we're going to convert this into this, and we're going to make a note, and it's worth making note of what a, x, y are. Now, one thing I'd probably recommend of a way of remembering this is reading out what this actually means, what question 1 actually reads. So question 1 reads 3, so 3 is our base number, 4 is the power, and that equals a number. Now, remembering with logs, the answer is the power. So how we can write this, or for number 1, is it's going to be log. Now our base number is 3, and this equals the power, which in this case is 4. Now for number 2, we've got log, our base number is 9, our answer in this is 3 because that's what the power is, and we've got 7 to 9 just there. Again, let me just write that a little bit neater. So the answer to that one is going to be log 9 to 7 to 9 equals 3. So our subject is going to be the power. So for number 3, here we've got log, our base number is 4, and the power is -2, and here we've got 1/16. So for number 4, we've got log, our base number is 16, our power is 1/2, and our answer in this case is 4. And for number 5, we've got log, our base number is 1/2, which I'm just going to write as 0.5, our power is 3, and our answer is 1/8. And for number 6, here we've got log, our base number is 12, our power is 0, and here we've got 1. So moving on to the next set of questions is evaluate each of these logarithms. Now for this, because of modern day calculators, you should have a button on your scientific calculator that looks like this, or something in this sort of notation. Now if you have got a button that looks like this, then all you then need to do is simply enter your base, enter the actual number, and press equals, and that is it. So it's quite rare for these questions to come up in your exam, but it is equally important that you know how to enter these types of numbers in your calculator. Now, going a little bit old school in terms of if we didn't have these calculators, what do these questions actually mean? So if we start off with number 1, so we've got log 3 of 27. So what we're trying to do, now what I'm going to do is I'm going to swap the numbers into rule 5, let's say, and just replace numbers. So here I'm wanting to work out what not log, so that's what we're trying to get rid of. Here we go. And so here I want 3 to the power of something equals 27. So when I enter this on my calculator, it's actually going to tell me 3 to the power of what gives me 27, which in this case is going to be 3. So for number 2, I've got log 5 of 125. Don't know where that closing bracket's gone. So basically what this is asking me is 5 to the power of what gives me 125, and we know that 5 to the power of 3 gives me 125. For number 3, we've got log 4 and 1 over 256. So basically what this is saying is 4 to the power of what gives me 1 over 256. Now as we've got a reciprocal, our power is going to be a negative, so it's going to be to the minus, and 4 to the power of what gives you 256, that'll be minus 4. For number 4, let's do that over here. So for number 4, we've got log 10, and that equals 0.0001. So what this is asking for is 10 to the power of what gives me 0.0001. Well, in that case, x is going to equal a negative number, and it'll be minus 3. And then finally for number 5, we've got log 2 to the 1024. So what this is asking me is 2 to the power of what gives me 1024, and if I type that into my calculator, I get x equals 10. So as I said, with these second examples, all we need to do is just type in the values into our calculator, and what it actually tells us is the power that we need to raise the base number to get the number that's in the brackets. Now in these examples, I've been asked to express each of these in terms of log A, log B. Now one thing you might notice is the fact that we're missing a base number in these questions. Now in this particular question, the base numbers are going to be the same, and as these are expressions and not equations, then the base number is not going to be needed. Now you might find later on when we're working with logs that the base number is usually missing. However, if this is the case, then what that basically means is that we're working with a fixed base of log 10. Now the reason why we work with log 10 is because that is basically how we count. We count in measures of 10, so we go from units, tens, hundreds, thousands, 10,000s, 100,000s, and every step you go along you're multiplying by a power of 10. So that's why we by default we always multiply by log base 10. But it doesn't really matter what our base is for these particular questions, because ultimately it's going to be the same for the left hand side as the right hand side, and really it doesn't really have much sort of hold in these particular questions. So again, what's worth doing is making a note of the log laws that we've mentioned previously, and in this particular question I'm going to be using rules 1, 2 and 3. And there's no constant in this, so I'll leaving step 4, which we'll move on to more when we're looking at solving equations involving logs. So going to this original question, so starting with question 1, and I'll try and talk you through. So question 1, I can literally just simply copy off what is on law 1. So here I've got log AB is going to be equal to log. So when do I multiply? What do I do when I'm multiplying my bases together? Well, I add the powers. So this is going to be log A plus log B, and there is my final answer. With regards to number 2, I've got log A squared B. So how I'm going to split this up, so as they're multiplying, I'm going to add, I can split these up by adding. So I've got log A squared plus log B. Now if you refer to law number 3, which is just here, when I've got a power, I can move that to the front. So what this then becomes is 2 log A plus log b. And it's just a more efficient way of writing these things. And likewise, if I had a number in front of a log, I would need to convert that into a power in order for me to then go the opposite direction. And again, we'll make more I'll go through that again when we go through the next set of examples. So the goes to number 3, we've got log, and we've got the square root of a. Now if you think back to what square root of a actually is, well, the square root of a is a to the power of a half. So I can then rewrite this as log a to the half, and using law number 3, I can write this as a half log a, and there is my final answer. For number 4, again, now we've got using division, so I've got log of a squared over b. So what do we do when we're dividing powers? We take them away. So this is going to be log of the numerator, which is a squared, minus log of the denominator, and again I move the 2 to the front, so it becomes 2 log a minus log b. And then for question number 5, here we've got log of a squared b cubed. So again, as I'm multiplying, I add the logs together, so I've got log a squared plus log b cubed, and again I can move the powers to the front, so it becomes log a plus 3 log b. Then for so moving on to question 6, we've got the log and we've got square root of a b. Now note that the square root is being square rooted by both a and b, so what we need to do is do a bit of rewriting. Now we know that square root of ab, another way of writing this, and if I've just put brackets around what's being square rooted, is ab and then bracket to the power of a half. So with this, what I'm going to do is I'm going to write this as log bracket ab to the power of a half. Then using law 3, I move the half to the front, so it becomes a half, and then what I'm then going to do is expand the ab, so that'll be log a plus log b, giving me a final answer of a half log a by expanding the brackets out plus a half log b. Now note how I'm not writing this as log a divided by 2, I'm just writing it as a multiple coefficients, because again you want to get used to, rather than having sort of fractions, have multiples where your coefficient is a fraction. So then moving on to question 7 and adopting a similar technique, we've got, now again with regards to this part here, I need to do a bit of rearranging. So 1 over a squared b can be written as a squared b, and as it's the whole reciprocal of both a squared b, that's going to be to the power of minus 1. So what I'm going to do is I'll write this as log, and then it's going to be a squared b to the power of minus 1. I move the minus to the front, so we'll just write log a squared b. And work with the square brackets first, so I've got minus 1, and that's going to be log a squared plus log b. Move the 2 to the front, so I've got minus 1, 2 log a plus log b, and then multiply everything by minus 1, so I get minus 2 log a minus log b. And then finally with question 6, again we need to do a bit of rearranging on this, or rewriting using indices. So what this would equal, another way of writing that, would be a squared b to the power of 1/6. So going back to this question, I'm going to rewrite the question as log of a squared b to the power of a 6. I'm just going to repeat the exact same process with what I did with example 7. So that's going to equal 1/6 of log a squared plus log b. Move the 2 to the front, so I've got a 1/6, 2 log a plus log b, and then multiply out the 1/6, so I get a 1/3 log a plus a sixth log b. So as you can see, in each of these, it's important that you understand the rules of logs and you're able to manipulate those rules of logs to work with these final answers. And so you can only use, and again the most important thing is you can only use these logs when you've got no coefficient at the front. So when it comes to working with these, obviously you can move the coefficient back and forth, but just remember that with regards to these logs and what this equals, that there is no numbers in the front. So you might want to do some rearranging first before you start applying to these rules, and hopefully we can go from there. So moving on to our next set of examples here, what we've been asked to do is express each of the following as a single logarithm. Now what we're going to be doing in this particular set of examples is we're going to be going from the right hand side of our laws of logarithms and moving it into the left hand side. Now one thing to note is that when we are working with the laws of logarithms from right to left, is that none of these have got coefficients in front of them. So if we do end up with any coefficients before we start using these laws of logarithms to go from the right hand side to left hand side, we need to remove any numbers that are in the front. And we do that by turning that coefficient into a power. So looking at question 1, so with question 1 we've got log 3 plus log 4. Now one thing that when you get comfortable with working with logs is you kind of need to think to yourself, is there a way I can write this as a power? Now in this particular case I can write 4 as 2 squared, but the problem with this is that if I then write log 4 as 2 as, sorry, let's not jump ahead too far, as log 2 squared, the 2 then comes to the front, so it becomes 2 log 2. But now because I've got this 2 at the front, I kind of can't go in the opposite direction. So I certainly wouldn't recommend simplifying any of your logs, because obviously it'll point where you're just going to add more work to yourself. So with regards to this particular question, the only thing you need to be looking out for are there any numbers in front of my logs? Well, in this case I haven't. So this, using law 1, is just simply going to be where I'm adding, I multiply the two numbers, so it's just going to be log of 3 times 4, which is log 12, and there is my final answer. Can I write 12 as a power? No, so that is the final answer. For question 2, here I've got log of 24 minus log 4, and again I've got no numbers in front of my log, so I can go straight into using law number 2, in which when I'm taking away I'm dividing, so I've got log of 24 over 4, which then becomes log 6. And again, ask yourself, can I write 6 as a power? No, I cannot, so that there is my final answer. Now if you're not too sure about me questioning can I write 6 as a power, hopefully it'll make sense in a couple of questions where that's going to be applicable. So for number 3, here we've got 2 log 3 plus log 4 minus log 12. Now here you can see I've got a number in the front, so what I need to do is I need to move this number from the front into a power. So what this then becomes is log 3 squared plus log 4 minus log 12. Now 3 squared is 9, so I can just write this as log 9 plus log 4 minus log 12. Now this is where it can slowly start getting a little bit interesting. Now as you can see that as I'm adding, now as I've got no numbers in front, so I can go straight into using my laws of logarithms. Now the question is, what do I do first? Do I times the 9 by the 4, or do I divide the 4 by the 12? Now generally speaking it doesn't really make a difference, but general rule of thumb is you do it from left to right. So what this is then going to become is log of 9 times 4 divided by 12, which then becomes log 36 over 12, which then gives me an answer of log 3. And then for question 4, let's have a look at question 4, which I'm just going to do over here. And so with question 4 I've got half log 80 minus a half log 5. So again what I need to do is I need to move these numbers and turn them into powers. So that's going to be log 80 of a half minus log 5 of a half. Now when I'm taking away, it turns into a divide, so I've got log of 80 over a half over 5 over a half. Now if you try and think to yourself, well, what does a power to the half actually represent? Well, it represents square root. So this then becomes log the square root of 80 over the square root of 5. Now if you remember your laws of surd, so again a lot of laws coming into play, when we've got a surd on the top and a surd at the bottom, I can just join it into 1. So I've got the log of the square root of 80 over 5, and 80 divided by 5 is 16, so it then becomes the square root of 16, which ultimately then comes down to log 4. Now I can write 4 as a power, so what we can then do is write this as log 2 squared, which then becomes 2 log 2. So when I was talking about in the previous examples, none of them were applicable of writing 12, 6 or 3 as a power of something, whereas when I've got log 4, I can write that as a power, and then from that I can move that to the front, giving me an answer that looks like this. Now, do you really need to go that extra step from doing all of this here that I've got in the yellow brackets? Well, it's important that you understand, particularly with show that questions, it's going to be important that you understand how to get from log 4 and turn that into 2 log 2. So let's just get rid of all of this so we can work through the next 5 examples. So looking at number 5, let's do some different colour. So number 5, we've got log 15 minus a half log 9. Now again, I'm going to move that coefficient over to the front, so I've got log 15 minus log 9 of a half. Now 9 to the half is 3 because it's the square root of 9, which is 3. So I can write this as log 15 minus log 3. Now with bit practice you can jump steps. I'm just showing you step by step so you get your head around it, as these are examples. So we get 15 minus, which means divide, so it's going to be 15 over 3, which then becomes log 5. And again, ask yourself, can I write 5 as a power? No, I cannot, so that there is my final answer. Moving on to question 6, here we've got letters involved, but again exactly the same. So I've got 2 log A minus log B minus log C. So again, first things first, move that 2 to the front, to the back I should say in this case. So it'd be 2 log A squared minus log B minus log C. So again, from this, now where it slowly starts getting a little bit complicated is that this then becomes divided by B divided by C. It's a case of working around what this actually means. Now from this, what this then becomes, if you treat it from left to right, this then becomes A squared divided by B divided by C. Now again, if we turn that into a fraction, we flip this second fraction, turn it into a time, so what this then becomes is A squared over BC. So I can write this as log A squared over BC. So it's worth just working around it, and sometimes you might need to look at the answers at the back, or you might need to look at a particular mark scheme just to make sure you're doing it right. But with practice it certainly does come, and sometimes you might find you get to a point where you're writing your answer, you look back at the back of the textbook or in the exam paper and they've written it slightly different, but as long as you can see where their answer comes from, you've got confidence there that you are doing the right thing. So moving on to question 7. So let's have a look at what we've got. So here we've got log A plus a half log B minus 3 log C. So again, I'm going to rewrite the second and third term, so that becomes log A plus log B to the power of a half minus log C cubed. Now again, what does this mean? Well, it means log a times square root or square root of b, or b to the power of a half, all divided by c cubed. So writing this out, I get log of a root b over c cubed, and there is my final answer. Now moving on to question 8. Now the key thing to note here is I've got a constant, and also we've now got bases in here. Now when we've got a particular constant, the bases do come into play, and I'll explain to you what we need to do. So with this, I've got log base 4x plus 2 log 4 3 plus 1. Now the problem we've got here is that I can't join these three logs together. Now I can work with the second one, so let's just do what we know so far. Is I can write this as log 4 3 squared plus 1. Now I can't join these three terms together because of this 1. So what I need to do is something a little bit clever, and that is by rewriting that 1 as log 4x plus log, I'm just going to write this as 9, plus, now if I write this as log 4 to the 4, now the reason why I'm writing this log 4 to the 4 is because in the first two terms I'm working with the base of 4, so using log 4 I can write it like so. So log 4 to the 4 is just going to equal 1, but I'm writing it in terms of logs, so I can now join these three terms together. So what this then becomes is log to the base 4, and it's going to be x times 9 times 4, which then becomes log 4 of 36x, and there is my final answer. So I could have written this as 6 squared, but again it's no point because obviously I've got the x in front, it's not all being squared, so I would leave that as my final answer. So moving on to our last example, which again is going to be using something very, very similar. So let's go for our last final colour. So number 9, we've got log AB minus 3 log AC plus 3. So first things first, let's rewrite this. So that's going to equal log A to the B, which is absolutely fine because I've got no numbers in front, minus log A to the C cubed plus, now 3, I'm going to write this as log, now because we're dealing with log base A, I'm going to write this as A, because again that bracket's just going to equal 1. And if I then simplify that further, log A C cubed plus log A to the A cubed. So what I've done is I've just moved that 3 over to the top. Now as you can see, my bases are all the same, so all I've got to do now is rewrite this. So I've got this as log to base A of B divided by C cubed times A cubed. And again, if you think to yourself, what does this mean? It means this. So from this, I can now, well, that then simplifies as being BA cubed over C, which we can swap these two things around so it's in alphabetical order. So what this then becomes is log A of A cubed B over C, and there is our final answer. Now with these particular questions, it does take a bit of practice. You may need to kind of refer, like if you're working in a textbook, constantly flicking back to the answers to see if you get the right answer. If just work through them. Now again, key thing to remember that if you do end up with something like log of, let's say, 9 as your final answer, it's worth just double checking of thinking to yourself, can I write this as a power of which this would be log 3 squared, and that then becomes 2 log 3. And likewise, if we had something like log 3 to the 9, well then that we can then simplify this as log 3 to 3 squared. The 2 moves to the front, and lo and behold, this thing here in the brackets then just equals 1, so your final answer will just equal 2. So although you may end up with an answer that's in terms of logs, you got to always try and think of, can you simplify it? And that's something that does take a bit of time, certainly does take a bit of practice for you to work through there. And sometimes it's a case of working through some quite complex examples just so you get an understanding of what you can do. And knowing what you can do is just by practice, and that's a key thing. If you have any questions about what we've discussed so far in this particular tutorial, feel free to drop me an email. And likewise, if you're wanting an accompanying worksheet for this, drop me an email at 162maths@gmail.com.